Alright, so as I mentioned on the previous video, now here we are going to see another case in recurrence relations. So I did mention in the previous examples of the questions we work on, we found that the roots of the polynomial are different. So when the roots are different, the general form will be an R1 C1 R1 to the power of n plus C2 R2 to the power of n. This one we use if the root of the polynomial are different. So we already done a few examples here. You can rewatch again the previous video. Now, if the roots of the polynomial are equal, so we would like to check whether this general form are still applicable. The fact it is not, then we are going to use another general form later on. Okay, so let's just work with this one. We are given here the recurrence relations an equal to 6 an minus 1 minus 9 an minus 2, and we would like to find out the general formula for the sequence if given initial condition a13 and a2 27. Okay, so let's just look at this one. So the first step that we need to do is to get the polynomial characteristic. So once we get the polynomial characteristic, then later we can find the roots of the polynomial. So we have an 6 an minus 1 minus 9 an minus 2. So if we move first, then we get 6 an minus 1 plus 9 an minus 2 equal to 0. So the sign also changed, right? So then this one will become x squared minus 6. This one an minus 1 will change to ax plus 9 an minus 2 will change to x. So we get 0. So this is the polynomial characteristic. Now next, what we need to get is the root of the polynomial. Make sure also when you are given problem later on, work according to the step, then that will be easy for you to work with it. So we have x squared minus 6x plus 9x equal to 0. So the root will be any number we add equal to minus 6, but when we multiply it must be 9. So what will be that number? So as I said, easier is you find the factorization of the multiplications, which is 9. So if you factorize 9, it should be 3, right? So 3 times 3 you got 9. But 3 plus 3 is equal to 6, but you're expecting minus 6. So instead of 3 we put minus 3 minus 3. Minus 3 plus minus 3 it become minus 6. But minus 3 times minus 3 become positive 9. So the number is minus 3 minus 3. So we get x minus 3 and then x minus 3. Alright. So here we get x equal to 3. From this one also we get x equal to 3. And this is what we said, they are equal. So when they are equal, this is what we do. The next step will be to determine the constants C1 and C2. So to do this, then this is the general form now, C1 R1 to the power of n plus C2 n r to the power of n. So this is where it differs. Over here we have another end which is not applicable if the roots are different. So only when the root of the polynomial are equal, then we have n component in the general form. Otherwise, all will be the same. Use the formula. So given initial value a1 equal to, what is the value just now? 3 and 27. So a1 3, a2 we get 27. So for n equal to 1, a1, then we have c1, our r is 3 to the power of n, plus c2, our c2n. Wait, I suppose just change immediately. Our n here should be 1 c2n, 1 times r. Sorry, our r again is 3 to the power of 1, which is a1 is equal to 3. So if we solve this, 3c1 plus this one, 3c2 is equal to 3. Now you can leave it as it is, 3c1 plus 3c2 equal to 3, but if you want to simplify, meaning all divided by 3, then you get c1 plus c2 equal to 3. So this will be the first equation. So from this we can get c1 will be 3 minus c2. This will not s2. Okay, so next, using A227, I'll just bring it here. So we have for A2 C1 R3 to the power of 2 plus C2 times N2 times R3 to the power of 2, which is equal to 27. So if we continue this, so we are going to have 3 to the power of 2 is 9. So 9c1 plus 3 to the power of 2 is also 9 times 2, we get 18c2 equal to 27. And this also have a common number. We can divide by 9. So if we divide by 9, we get c1 plus 2c2 equal to 3. So this will be our equation 3. So we have this all 1, 2, 3. Now we can calculate. So from 2, substitute. What is this? Hold on. So yeah, suddenly I forgot how to write down. Substitute. From 2 substitute to 3. So C1 plus 2C2 equal to 3. And then the C1 from 2 we got, which is 3 minus C2 plus 2C2 equal to 3. So we have hold on, 3, and then minus C2 plus 2C2, so we have C2, so equal to 3. So in this case, C2 is equal to 3 minus 3 equal to 0. So C2 is 0. What will be C1? So C1 is again from 2, 3 minus C2. So 3 minus C2. So it's 3 minus 0. We get 3. Fine. So we find C1 equal to 3 and then C2 equal to 0. So Step 4, substitute this C1 and C2 to general formula, which is we already put it. Where is it? Where we put? Nah, here. Okay, this one. Let me just duplicate. Okay, and then our R1 is equal to R2 because they are equal 3. So when we put, we have an C1 is 3, R1 is 3 to the power of n, plus C2 is 0. This is 0, yeah, but I will review back why is it 0. I'm not expecting 0 here. N is n times R, 3 to the power of n. So we have n 3, so 3n plus 1 plus 0 times any number here, that will be 0. So the final one will be 3n plus 1. Alright, but let us review back, because as I mentioned earlier, I'm not expecting 0 here. So let's just do it slowly from here. So from here, we already have C1, the root of the polynomial 3. So starting here, A1 3, so we substitute A1, and then C1 3 to the power of 1, and then C2 1 3 to the power of 1 equal to 3. Hold on, is it a mistake or not? Correct. So from here, correct, we have 3C1 3C2, correct, equal to 3. So C1 plus C2 equal to 3, correct, and then C1 will be 3 minus C2, correct. So no problem in there. Start with A2 27, and then A2 C1 3 to the power of 2, yes, correct. C2 2 3 to the power of 2, also correct, no problem, equal to 27, right. 3 to the power of 2 is 9, C1 3 to the power of 2 is 9 times 2 18, correct, 27, correct. So we divide by 9, this one becomes C1, this one 2C2, this one become 3. Okay, fine. Next, so we substitute 2 to 2, we get C1 plus 2C2 3, while C1 earlier is 3 minus C2, okay, plus 2C2 equal to 3. Okay, so far so good. 3 minus C2 plus 2C2, we get C2, and then C2 is 3 minus 2 is 0. It's fine, it's good. Alright, so let's just, okay, we got this final. Let's just prove it whether it is correct or not. So we check with this one. We have A1 and A2 already calculated. So A1 is 3, A2 is 27. Let's just use this formula. So for n equal to 1, so we will get A1 equal to 3, 1 plus 1. Hold on. When we get 9, cannot be. And then n equal to 2, so A2 is 3, 2 plus 1 which is 3 to the power of 3, 27. It's correct for the N2, but something wrong here. I get 9, supposed to be 3. Let's check again. Where do I do the mistake? Okay, hold on.